Hey, Nathan here. Welcome back to another video game algorithms tutorial. Last video game mathematics video, we took a in-depth look on the mathematics behind Bezier curves, and it's essentially a lerp from all points that are in a list, and you repeat that process until you only get 1 point at the end. So if you have 4 points, you can alert between points 1 and 2, 2 and 3, 3 and 4. So that will result in 3 points, so you repeat the process. That will result in 2 points, so you repeat the process again with those 2 points, and then that will give you only 1 point, and that is the end of the work that you need to do. So that's the basics on this Bezier curve, is that you have a list of points and you lerp on all those points and you get a list of points as a result. And you repeat that process until you get only 1 point left, and then that's the point that is actually on the curve. So now let's take a look at the actual algorithm. So let me discuss what the algorithm is. There's a few ways you can do this. I took the mathematics, the definition of the recursive definition of Bezier curves, and just translated that into code. You could do an iterative instead of a recursive. Just do that until you only get one element in a list as a result. You can combine the two, do it recursive. You get a list of points as a result of all the lerps. If it's not 1, if it's greater than 1, do another recursive call. And when it's 1, you can just return that one single point. So this version is a little bit different than the repeated call with only the subset points as a result. So we have a list of points that we get in our algorithm. If the points only contain one result, we will return the point. Otherwise, it'll at least contain 2 points. We need to get a recursive call to send it a list of points with the last one taken out. And then we need to do another recursive call with the first one taken out. So we take the last element out of the list for the first recursive call, and we take the first element out of the list on the second recursive call. And then we repeat that process. It'll do a recursive call. And then we get 2 points as a result, and then we just return the 1 minus t times the first result plus t times the second result. So let's take an example and let's walk through this. So consider an example where we have 4 points: P0, P1, P2, P3. We send that to this algorithm, so we have 4 points in our list. The first recursive call, remember, we want to take the last element out. So I'm going to walk through this call by call. So 4 points is greater than 1, so we need to go to the recursive calls section of our algorithm. We take the last element out of the list. So that means we're recursively calling the algorithm with P0, P1, and P2. Okay, that's still 3 points, so we need to do another recursive call. We take the last one out, so we're recursively calling it again with only P0 and P1. Again, that's 2 points. So we need to do the same thing. We need to call it again and take the last one out, which will just be P0. That's only 1, so we get that as a result. So we get P0 as a result. Now that same stack, we're going to do the other recursive call, which, remember, the second one takes the first element out. So we're going to call get points, and we're going to pass it P1. That's only 1 point, so we get that as a result. So now we have 2 points as a result. We're going to lerp between those 2 points, which will give us only 1 point. Now we go back up the stack, and that gets set to, we'll call that A. Now the next thing we want to do is to do the recursive call with the first point out. Remember, this is the stack that only has P0, P1, and P2. So we finished the first section, which was taking the last element out. So now we need to take the first element out. So we're calling get points with P1 and P2 now. And this will be more evident in the video. When I indent, you can see the actual what call and what stack it's on. So we're calling get points with P1 and P2. Remember, we want to take the first one out, which was P0. So that's 2 points. So we need to do 2 recursive call, one with P1 and one with P2. Those will give us 1 point each, which will result in 2 points that we can lerp between those 2 points, and we will return that, and that will give us, we'll assign it B. So now on this stack, we have both A and B, 2 points. We can successfully lerp between those two to only gain 1 point, so we return a lerp between A and B, and we'll assign that E, let's say. Alright, so now we're back on the main stack where we had all of our points. So that was all the first line of the main stack. The second line, remember, takes the first element out of the list. So we're going to do a recursive call with points P1, P2, and P3. And then we're going to do a recursive call with points P1 and P2. Again, that's only 2 points. So we're going to do a recursive call, one with only P1 and one with only P2. Those are the basic recursive definitions where we just return that 1 point. So now we get 2 points, so we can successfully lerp between those two. And we'll assign that C, let's say. The next one on that stack, remember we want to take the first element out, which is a recursive call to points 2 and 3. Those are 2 points, so we need to do recursive call, one with P2 and one with P3. Those give us 2 points as a result, and we can lerp between those 2 points, which will give us 1 point, and we'll assign that to point D. Now, we will lerp between points C and D, and that will give us a result F. So now we're back on the main stack with where we had all of our points in that list, and we only have 2 points as a result. Lerping between 2 points gives us 1 point, and that's our end result, and that's what we're looking for. So we just lerp between E and F, and that is our end result. So definitely the video overlay that I'll be doing as I'm discussing this will help you out. Every indentation of the algorithm that I just walked through is a stack. So that is the basic algorithms. You can do it with just a simple for loop or do while loop or anything like that. All you're looking for is a 1 point as a result. If you have more than one element in a list, you need to lerp on those points until you only get 1 point. So it might be easier for you if you do it as a do while loop and you have like an internal a separate list that you contain as like a resulting list. This is another version of the algorithm you can implement. So let's say you have the main algorithm takes a list of points, and inside the code you have another list where you named it resulting point set. You lerp between all the points in the list, and then you assign that to the resulting set. Then you do a while while the resulting set.count is greater than 1, you repeat the process. And then you do a lerp between all the resulting sets and then reassign it to the resulting sets. Again, repeat it since it will be greater than 1. And when it equals 1, the only element left in that resulting set list will be 1 point, and that's your result. So if you take a look on the mathematics of Bezier curves, there is a recursive definition in mathematics terms of how a Bezier curve works. And I just translated that to an algorithm. It's the recursive definition. If a set has only 1 point, it returns that point. Otherwise, it returns, you add up you lerp between a point with the first element out and between a point of the last element out. Okay, so let's take a look at the code here. This will be in the description. I didn't bother programming in this video because it's more of an algorithm discussion than an actual type as I record the video type of tutorial. So the algorithm and everything's all complete. Most of this code here is to create a visual representation of what's going on. So like this, draw sublines and draw subpoints and draw points. This is mostly the code that's going on here. It is typically to have us visualize what's going on. This is the main algorithm that's driving this. So we get a list of points that we want to get the end result, get a point on the Bezier curve. If that only contains one element, that's what we're looking for, so we just return that one element. Otherwise, it's going to at least have 2 elements. So the first call, we're going to take the last element out of the list. So the way I did this is to do a .take on the list and do a count -1. So, for example, those of you that aren't familiar with the .take method call, let's say we have a list of points and the count is 4. So this right here, 4 minus 1 is 3. So we're only going to take 3 elements out of the list. And I just did a .to list here to make it easier. So we're taking the first 3 out of the list and doing a recursive call. So we're avoiding the last point in the list. The second recursive call does the opposite. We're avoiding the first element of the list and doing a recursive call. So you just do that by .skip. So you're skipping the first element and then getting a subset of points there. And I just do a .to list to make it easier. So eventually, we don't know if this list has only 2 points or if it has 1,000,000 points. Eventually, we will get a result where we just have 2 points, because this, if it's 1,000,000 points, this will have a recursive call, which will have a recursive call in that, which will have a recursive call in that. But once we pop up the stack again, we will eventually only end up with 2 points. And remember, the goal is to get down to 1 point. So what do we do if we only have 2 points? We just lerp between those 2 points, which is 1 minus t times the first point, I assigned it PA in this algorithm, plus t times the second point. And that will give us our result. So very easy algorithm. Only 4 lines of code there. If you're more comfortable with like a do while, like I mentioned before, that's entirely up to you. It doesn't matter how you do that as long as you achieve it and it's up to your performance standards. I don't want to say that there's no wrong way to do that, because you can do it recursively, you can do it iteratively, you can do it a mix. Like if we have a list of 4 points, I could change this up where I lerp on all those 4 points, which will give me a subset of points. And if that subset of points is greater than 1, I do a recursive call with only that subset and repeat the process. So I could do it a kind of a mix where I do get that subset and then do a recursive call, or I could just do it like I have here. Update, that's pretty self-explanatory. I just take remember how I mentioned, if you haven't seen the mathematics video, I'll mention it again here, is that t has to be between 0 and 1 for this to work. So if you want a bullet or some kind of game object to have travel along this path for, let's say, 5, 6, 7 seconds, you have to have an internal clock or internal representation of how to handle to convert that 6, 7 seconds to a value between 0 and 1. So elapsed time is simply how much time has elapsed since the Bezier curve has been created. And then the total time, so it'll be elapsed time divided by total time, and that will give you a value between 0 and 1. If it's greater than or equal to 1, we'll assign it to finished. And if the last point does not equal the last point of the list, we'll just add it to the last point. Because when t is 0, the object will be at the first point of the list. When t is 1, it'll be on the last point of the list. So we make sure that when we have finished, we make sure that the points on the curve contain the last point of the list. If we have not finished, we just get the current point on the curve. I did add pausing and reset functionality in this. That way we can pause it during some session and take a look at what's going on and then resume it, and then reset it if we need to do that. And then all this stuff is drawing, how to draw it. You can take a look at how to do that if you want. This isn't really about how to draw lines and that kind of thing, so I'm not going to go over that. Okay, this is the example that I provided at the beginning of the video, just so I could discuss that. Alright. This is the main game class, and like I mentioned in the mathematics video, I will mention this here as well for those of you that haven't watched the mathematics video. This is implemented to where you can have 2 points, which will just be a line, or you could have 1,000,000 points. There's different definitions if it's a cubic or quadratic Bezier curve and that kind of thing. This is set up to where you can have any elements you'd like. But just by driving this algorithm, it doesn't care how many elements are in this collection. It could be 2 points, it could even be 1 point, which will mean you don't really move at all. It could be 1,000,000 points, and then you just have that giant recursive call with 1,000,000 points. This example, realistically, you're not going to have 1,000,000 points. This example, I have added 7 points into my list array. And then I tell the Bezier curve how long I want it to be. In this case, I want it to be 60 seconds, and all my points. And then I use the keyboard to determine if it should be paused or reset. And then I just update it by passing the elapsed game time total seconds. That will generate a new point on the curve. And then I just draw all those points and the main point. Alright, so let's take a look. I'll press F5. I'll leave it as 60 seconds so we can see what's going on. Again, this is 7 points. Now, I decided to draw all these sublines. So you see blue, that's the first iteration, the first looping. So that gives us the most resulting points in the list. And then green is the second most, and then just red from there on. So our goal is to get down to 1 point, so we lerp between all these 7 points, and that will give us a resulting set that you see in blue. That is not 1 point. So then we do it again, and that will give us a green result, and we'll just repeat the process until we end with 1 single point at the end. And there you go. It has finished, and that is the curve, that is the path that the object took to get to the destination. Alright. So this, you don't have to worry about doing anything weird here. You can have it, I'll just take 1 point out, and the curve will be different. The path will be different. It won't be too different, but it'll be different. And let me actually speed this up. I'm going to make this, let's say, 10 seconds. So now we can see the path that it's taking. So this is a different path. Remember the last path that had that loop and went back down to the right? This path didn't do that. And all we did to get a different result was to take that point out. So now let's take this point out. So now you can see how much of a difference just adding and removing points can make on the curve. So here we see this is the path that it took to get to the end result. So take a look at the code. Hopefully this video explained the algorithm I decided to choose. It's a very short algorithm, only 4 lines of code. I don't consider counting the white spaces, so just 4 lines of code here to achieve that result. Very basic. The mathematics was definitely a lot more of an in-depth discussion than the algorithm. So take a look at the code. If you have any interest in how I'm drawing it, feel free to look at the drawing as well. And that's it for this video. I hope you enjoyed it. Let me know if you have any questions. I'll be sure to answer any questions you might have. Comment below. Join me on my Discord. Hopefully we can get that going pretty quickly. Stay tuned for the next video. If you have anything that you want to learn, either mathematics or algorithms, let me know. I'm open to suggestions. Otherwise, I'll pick something on a list of my topics. I haven't decided what the next one would be. Alright, oh, by the way, I implemented this where you cannot provide it in negative seconds or 0 seconds, and it has to be at least 2 or more points, since 1 point on the Bezier curve isn't really a Bezier curve at that point. Okay, so I hope to see you next time. Thanks for watching, and let me know if you have any questions in the comments or Discord. Bye. Well, thanks for watching. I hope you enjoyed this. Please give a thumbs up or a like if you enjoyed this. Add a comment if you want to as well. Feel free to take this link and share it, put it on your own site, embed it, whatever you want to do. That's fine with me. Anything that I mentioned that you need resources, be sure to check the description below. There will be links for those. If I missed anything or if a link is dead, please post a comment or find a way to contact me. You can go to my website and use the contact form. Want to be sure that all the links are still live and going. So, stay tuned for the next video.